Hello students, in previous lecture we have studied the basic proportionality theorem which is related with the area of triangle and ratios of areas of two different triangles. Then one more theorem, that is the property of triangle, which is we have to prove that property of triangle. That means here one more theorem which is related with the triangle is going to discussing here. That is, see here, that theorem is property of angle bisector theorem of triangle. That means, see here, what is angle bisector of triangle? Suppose the triangle PQR, in which if the ray PS which divides the angle QPR into equal measurement, then ray PS is the angle bisector of angle QPR. Then see here, what is angle bisector? The ray which passing through the point P, that is vertices P, that divides that angle of triangle into equal measurement, then ray PS is a angle bisector. Then see here, the property or theorem which is related with the angle bisector of triangle, that is, in this triangle, that is triangle ABC, in which CE, ray CE is a angle bisector of angle ACB, and that angle bisector of this triangle intersects to the opposite side of that angle AB at point E, and therefore that angle bisector ray CE divides AB into two parts. And see here, then the property of angle bisector is the bisector of an triangle. That means the bisector of an triangle which divides the side opposite to that angle. It divides the side opposite to that angle in the ratio of remaining sides. That means here the angle bisector C divides the opposite side of angle ACB, and the parts which is obtained, this divided part, ratio of these divided part of the side AB is equals to the ratio of remaining two sides. That means we have to write first the given concept given here, that is in the given. See here, in triangle ACB, see here, ray CE, which is a angle bisector of angle ACB ACB, and ray CE divides side AB into two parts. That is, ray CE divides AB into two parts. That means ray CE intersects side AB at point E. Then, and here angle ACB divided into equal major angles. Therefore, here angle ACE is equals to angle ECB. And see here, we have to prove that here the side AB divided into two parts, the ratio of these two divided parts, that is AE upon EB, is equals to ratio of remaining two sides, means AE corresponds with AC upon EB corresponds with CB or BC. That we have to prove here. For this purpose, we have to do some construction here. That is, here the line parallel to CE, ray CE, which is passing through point B, should be drawn here. That is, this line which is parallel to the ray CE, which is passing through point B, and side AC extended up to the ray, that is, which is intersects at point D. Then that is the construction. Then we have to write here, that is, draw construction, draw ray BD, draw ray BD parallel to the ray CE, and then extend the side AC, that is, extend the side AC such that it intersect to the ray BD at point D. Then see here the construction. Ray BD is drawn, which is parallel to the ray CE, and the line segment AC extended to intersect it BD at point D. Then proof, which is given here, that is, proof of this property or theorem. That is, see here, first of all we have to write the few concept which is in given. That is, here the ray BD parallel to the ray CE. See here, ray BD parallel to ray, that is CE. That is our construction. And transversal, considering transversal, that is, see here, that CE ray parallel to the BD, and transversal AD is considered here, AD transversal. Then consider only the line or ray CE parallel to the ray BD and transversal AD. Transversal AD. Therefore, in here, angle ACE, that is this angle, is equals to this angle. That means these are the line parallel to each other, and that is the transversal AD. Therefore, these two angles are congruent. Why? Because corresponding angles are there. These are corresponding angles. Therefore, angle ACE congruent angle or equals to the measure of these angles are equals to the angle ADB, and angle ADB means it is an angle CDB. Therefore, angle ACE is equals to angle CDB. Let this equation 1. It is because of these are corresponding angles. Corresponding angles. Then again, see here, the ray BC, side BC of triangle. Then see here, again the ray CE parallel to the BD. Ray CE parallel to the ray BD, and now the transversal BC is considering it. BC. Then these lines are parallel and the transversal BC. Therefore, this angle, that is angle ECB, congruent angle CBD. Then see here, transversal BC is considered here. Therefore, angle ECB equals to angle CBD. That is equation number 2. Then angle ECB and angle CBD, these are congruent because these are alternate angles. Alternate angles. Then see here, but we know that angle ACE and angle ECB are congruent because it is given angle ACE is equals to angle ECB. That are given, and that is the equation number 3. From equation 1 2 and 3. Then see here, angle ACB congruent with CDB and angle ECB congruent with CBD. And in third equation, angle ACB ACE equals to angle ECB. These both angles are congruent. Therefore, here angle CDB is equals to angle CBD. Therefore, angle CDB equals to angle CBD. That is the equation number 4. Then see here, angle CDB and angle CBD are congruent. Therefore, in triangle that is CBD, in this triangle it is a isosceles triangle because their base angles are congruent. When base angles are congruent, then that is a isosceles triangle. Therefore, here BC congruent CD. Therefore, triangle CBD is isosceles triangle. Therefore, BC congruent CD. BC congruent CD. That is the equation number 5. Then see here, there are two sides which is congruent in isosceles triangle of CBD. Then in equation A, B and D, that is greater triangle. Then see here, in triangle ABD, see here, EC parallel to BD. Therefore, according to BPT theorem, AC upon CD is equals to, see here, AE upon EB. AE upon EB. Then let this equation number 6. But see here, BC, that means BC means CB is equals to CD. Therefore, CB and CD are congruent. That is CB and CD are congruent. Therefore, here putting the value of CB in equation, this in the place of CD. Therefore, we get the equation number 6 becomes AC upon CD. CD means CB. AC upon CB is equals to AE upon EB. And that is the, therefore AE upon EB is equals to AC upon CB. That is the proof of this property or that theorem. That is the angle bisector theorem. That means when in any triangle the angle bisector divides the side of the triangle, that is, it divides to the opposite side of triangle in the ratio of remaining two sides. That means, see here, in PQR triangle, if PT is a angle bisector which divides QR into, that is intersects QR at point T. Then according to this theorem, see here, that is here QT upon TR is equals to QT upon TR is equals to QP upon PR. That is the property of angle bisector of triangle. Then we can write the converse of that angle triangle also. Then what is the converse of that angle triangle? See here, if the line or the ray in triangle, it divides the opposite side and into the equal ratio of remaining two sides, then it is a angle bisector of that triangle. That is the converse of that given theorem. Both converse as well as this theorem is used to solve the examples from exercise or practice set 1.2. Now we will solve few examples from practice set 1.2, which is based on basic proportionality theorem as well as angle bisector theorem. Then see here, in question number 1, there are few figures are given there, and the question that is given here, given below are some triangles and lengths of few line segments are given here. Then identify in which figure ray PM is a bisector of angle QPR. That is the example, and the figures, that is triangles, are given here. That is one of the triangle which is I am going to draw here. That is one of the example, that is which is related with the angle bisector theorem. That is example number 3 from question number 1. Then see here, the triangle PQR is given here, and that ray PM intersects QR, the third side QR, into, it divides to the side QR into two parts, that is QM and RM. And here the values of few line segments are given here. That is here QM is given 3.6, RM is given here, that is 4, and PR is given here 10 units, while PQ is given here 9 units. Then see here, we have to determine whether that ray PM is a angle bisector of that angle QPR of that triangle or not. Then for that purpose, first we have to write the given values of the sides or line segments given in the figure or given in the examples. Then see here, given in triangle PQR, in triangle PQR. Ray PR, ray PM intersects to the side QR, to side QR at point M, at point M, and QR divides into two parts, and here the line segments, the values of lengths of few line segments are given here. Therefore, QM is given here, that is 3.6. RM, that is 4 units. QP is given here, that is 9. And PR is given here, that is 10 units. Then, using these values of few line segments and using the angle bisector theorem and converse of angle bisector theorem. All of you aware of that? What is the converse of angle bisector theorem of triangle? If the ray of triangle which passing through the one of the vertices of triangle, if that ray divides the side, one of the side of triangle into equal ratio of remaining two sides, then that ray is an angle bisector of that angle in the triangle. Then first of all, we have to prove that whether these two sides, ratio of these two divided parts, line segments, is equals to the ratio of remaining two sides or not. Then first of all, we have to write the ratio of these two line segments, that is here QM upon RM is equals to, then put down the value of QM and MR, that is 3.6 upon 4. We have to simplify this. 3.6 is there, therefore it should be written like this, 36 upon 40. Then to simplify this equation, that is 4 ones are 4, 0, 4 9s are 36. Therefore 9 upon 10, that means 0.9 is there. Let this equation number 1. Similarly, we have to write the QP upon PR is equals to, then QP or PQ is given here, 9 upon, that is PR, 10 is equals to 9 upon 10, that is 0.9. Let this equation number 2. Then see, from equation 1 and 2, the ratios of QM upon RM and QP upon PR are equal. Therefore, QM upon RM is equals to QP upon PR. Therefore, see here, the ratio of QM upon RM is equals to ratio of PQ upon PR. Therefore, ray PM is angle bisector of angle QPR. Therefore, rapium is angle bisector of angle QPR. Similarly, there are few more examples in practice set 1.2, which is based on angle bisector theorem as well as BPT theorem. We will solve these examples in next period or next lecture. Thank you.